Hello, my name is Blaženka Divjak, and I'm going to chair this session. So welcome. I would like to welcome you all at this presentation. And you know that we are in the second week of our conference, and today's presentation, the title is Diagnostic Testing with Numbas. And this presentation is going to be delivered by Don Shearman and Jim Pettigrew. And of course, at the beginning, I would like to greet them and also to give them opportunity to explain, to present, and after that, the audience, we will have opportunity to ask questions. And please use this matrix text chat for questions and discussion. You can find the link in chat here, and just put the questions there or comments. So after the presentation, I know that Don and Jim will answer the questions. So Don and Jim, the floor is yours.
Thanks, thanks, Blaženka, and thanks everyone for coming along. Good evening. It's 6:30 here. As you can see from Jim's screen, we're from Western Sydney University. Jim's a little more corporate than I am. I'm in a shearing shed somewhere in the middle of nowhere. We're going to talk about the diagnostic test algorithm and process that's been built into Numbas. I think Christian released it last year, possibly at this time, or maybe the year before. I don't remember, but we certainly got interested in it late last year and have started using it. And so we thought we'd share what we've found. So Jim, do you want to jump onto the next? So, like everybody, we have students who are poorly prepared for their university study. I think that's become a global thing. We, in the past, had an online refresher. We had a face-to-face refresher course called Math Start, which has been running since time immemorial at the start of the academic year. With COVID, of course, that had to move online. And so what we were trying to do is find a way for students who come into the first of the modules for this Math Start system to figure out what they know, what they don't know, which parts of the module they need to focus on. And so we wanted some sort of automated system that diagnoses their needs and then recommends the focus areas for them. We decided to run with the Numbas diagnostic test algorithm, and fortunately, and again typical, at the end of last year, academic years in Australia run from January to December, and I think around the end of November, the DVC academic told us that there was some money in the pot that we could use, but it had to be used before the 20th of December or something. So this was a very rapid development process. So, as I said, we developed this tool that's based on the existing online refresher module called Algebra 1. Math Start has two algebra modules, trigonometry, calculus and statistics. And we've developed, does somebody else have somebody singing in the background, or is that just me?
That's my daughter's just home from singing lessons.
Ah,
so I'll just
But it sounds good, so.
It does. I just wondered where it came from.
I'll just mute myself, sorry.
Okay, sorry, Jim. So we're just focusing on the Algebra 1 diagnostic test. We actually built diagnostic tests for 4 of the 5 modules in Math Start, but the Algebra 1 has had the most use, and so we've got more data from it. Designed for the diagnostic test basically needs 2 things. It needs, the essential part is a knowledge map, which I'll explain a little bit more in a minute. And then using that knowledge map, we built the diagnostic tool in Numbas, which uses this map. So the diagnostic tool in Numbas is an adaptive computer test. so that it doesn't ask the student every question that's in the test. The next question that a student gets depends on their answer to the question that they're answering now. And depending on whether they get the current question right or wrong, it also then marks or infers that other questions will be either right or wrong, depending again on this knowledge map. So we've kind of done things backwards because, in many ways, because now after the event, we're reading some of the publications on some of the research on computer adaptive tests. And the suggestion there is that you take a lot of questions, collect data on all of the body of questions, and then use some factor analysis and various other statistical techniques to infer the knowledge map. We kind of went backwards, and because we felt that we knew the Algebra 1 module fairly well, we developed the knowledge map based on the content and then adapted questions to that knowledge map. And so now, as we'll see in a minute when Jim talks about the analysis side, we're trying to check that what we've done in the knowledge map is correct and questions are working the way that we expect them. To get a handle on this knowledge map, my process was to take Christian's diagnosis test, which is available in the public part of Numbas, and reverse engineer the knowledge map of that based on the linkages that are implied in the test. It was an interesting afternoon's experience trying to build this thing from the questions, but it certainly gave me a much deeper understanding of how the test works. So the knowledge map for our test, and the knowledge map for any test, is a directed acyclic graph where each of the nodes is a question, and the linkages are linkages which suggest that one node or one question leads to another. In this illustration, or in this version of the map, which I've built in Gephi, down the page means leads to. Anything that's higher on the page depends on something that's anything that's lower on the page depends on something higher on the page that it's linked to, if that makes sense. And there's also, sorry, just one more thing in that, Jim, there's also in here the learning outcomes. So anything here that has a number attached to it represents a question, and anything that doesn't have a number, for instance, right at the top of the page, algebraic expressions, was one of the, well, we call them topics in the module, but in the diagnostic test speak, these are called the learning outcomes.
And the questions are called topics, aren't they?
And the questions are called topics, yeah. So we sort of have a bit of confusion around naming, which is nothing compared to the various numbering systems for the questions that we ended up with in the analysis. But from this knowledge map, we then, with some help from another member of staff, developed questions for each of these and built the test. So, as I said before, the diagnostic exam type allows questions to be arranged using this directed acyclic graph, or a Bayesian network, if you like. And the way it works is that if you get an answer to a question wrong, then any question that's harder than that question, any question which depends on that question, is also marked as wrong. And if you get a question correct, any question which leads into that question is marked as right. So we sort of think of it as the zeros dropping in the knowledge map and the ones floating to the top. So for instance, if you got question 631, if you were presented with question 631, equation of a line, and you got that correct, then anything above that that's higher than that and connected to it on the knowledge map would be also assumed to be correct. Conversely, if you got something like presented with something like 501 and you got it wrong, then 511 and 631 would be marked as incorrect or assumed to be incorrect.
Because they're quote unquote harder.
Yeah, the assumption is that these questions are getting harder, that they depend on and use the concepts from earlier on. Okay, so 3 steps in building the process after we created the knowledge map was firstly finding questions for each of these topics in the knowledge map. And again, fortunately, we had a lot of questions that were already in use in Algebra 1. And so we were able to, in some cases, adapt, in some cases, just use those questions directly. And then within Numbas, you create the once you create an exam and nominate it to be a diagnostic type exam, you then have to create these learning outcomes and the topics, and then link all of these things together using these depends on and leads to directives. And I think our next picture is an image of, so the development here was recursive. As we started developing questions, we sometimes realized that a question or a concept that we'd found or put into the knowledge map was really 2 concepts, and so we needed to stretch it out. I don't think at any time we collapsed concepts, but we certainly added some extra concepts as we were going, because one question couldn't test what we needed. So the numbering authoring, this was what I was referring to before. The authoring interface allows for fairly easy topic linking. On the left-hand side there are the list of topics, and you can see topic 101 is highlighted, and then that topic leads to several other topics which we
can see in here actually. So 101 leads to 102, 106, etc. And I think we can see that here. There's 101 there, order of operations. It leads to 106, 102, etc. 105 will be there as well.
Yep. And then it belongs to the learning outcome of algebraic expressions.
Yeah. Did we mention, Don, that we use the structure of the topics and subtopics within the Algebra 1 Math Start module as our sort of first approximation of the knowledge map?
Not entirely, but yeah, that's a good point. So our learning outcomes, our module in Math Start had 6 topics. Algebraic expressions was 1. There were 5 others. So we took those to be the learning outcomes, and then we used the content of the subtopics and the learning outcomes for the topics to create the knowledge map. The tool was offered to students for the first time in February. It's been available to students continuously since then. I also coordinate a mathematics for engineers preliminary subject at the university, and I've pushed all my students to do it. So by last Thursday, we had 715 attempts by 521 students. Some students have come in, just looked at the test and decided they didn't want to do it for whatever reason. So not all of those 715 attempts are complete. We have some where they've done part of the test and then stopped, and Jim will say a little more about that in the analysis. And some just haven't done any questions. So Jim, over to you and the analysis.
All right, thanks, Don. So we've had a lot of students now, as we've just seen, attempt this. We're calling it a tool.
Yeah, we try to avoid the word test in it to try and make students think that it wasn't a test. I don't know that it was completely successful.
Well, I mean, I think everyone just ended up calling it a test anyway. But so we've gathered a lot of data, and so just in the last couple of months, Don, myself, and a colleague of ours, actually, Shartha Aziz is her name. She has had a big role in developing the knowledge map and also the tool itself. The 3 of us have been meeting fairly regularly to talk about this problem of how to validate ultimately the knowledge map. This is something that has been put together by a group of experienced mathematics educators, And so, we're confident that, all of the connections, directed connections in this graph are roughly right. That, for example, the skills required to master a question of this type, order of operations, would be needed to master a question of this type, expand brackets, where we're considering direction here in this graph going down. But that's perhaps heuristic. That's a group of humans applying their knowledge and experience to the problem of how to set up, what you might think of as an implication network here. We thought it might be interesting to see if we could use the data, now that we've got this rich data set, to apply statistical techniques to this problem and see whether some kind of statistical analysis could shed light on this question of whether or not the knowledge map is valid. So that's sort of the broad project. And it's turned out to be one that, well, it's a multi-headed hydra, really. So as we've been digging deeper into the research base and so on, and learning about, well, Don mentioned, Bayesian networks, and various other sort of techniques involving computer adaptive testing models. We have found that there's quite a few ways we could go. So we can talk a little bit about some of the more sort of sophisticated statistical analysis directions we've taken, perhaps later. But to begin with, we weren't too fancy. We did apply some modelling, just one parameter rash modelling or logistic regression, and that's already borne a bit of fruit. There are a whole lot of problems with it. It's been very fast and loose what we've done. But it's a work in progress. So we've just kind of made a start using rash modeling, which I'll explain in a second. But before we did any modeling, we just had we had a good look at the data, and even just taking a big JSON file, which is the way that Numbas kind of delivers or packages this attempt data. Even digging into that using R is the way we did it. Has unearthed a few interesting problems and considerations. For example, we've seen that some students, quite a few actually, quit the tool once they got a question wrong or several questions. Some looked ahead and then quit, and quite a number of students took a very long time to complete the tool. And by complete, what we mean is sort of exhaust the tool, so that they've been asked every question that the tool is sort of designed to deliver to them. We also found that there's... Oh, sorry, Don.
Sorry, Jim, I was just going to say, I think the median time for the test is around 45 minutes. It's hard to determine because some students don't close the browser window, so you've got some that are there for 2 days. But from memory, I think between 30 minutes to an hour is about from Q1 to Q3 of the data. So most students or half the students are between half an hour and an hour who complete the test.
And there are obvious design questions for us to think about there, because if it is taking a good number of students 45, 60 minutes, then that'll probably have a negative impact on engagement. We would imagine that a lot of students would just give up. They would think, well, this might be useful for me, but I'm not prepared to spend an hour to find out how useful it might be. So yeah, that sort of leads to this sort of question of feature improvements. So now that we've had a close look at how the tool works, one thing we thought might improve it is how the system selects the next question to deliver to the student. So if they're on a pathway here, and if they're at the bottom, so this is 631 equation of a line, if they get that wrong, then Don, tell me if I'm right here, the system will do something like deliver them the next easiest one on that pathway.
Yep.
What it could be doing is it could be taking them a bit further up. It could be using some kind of binary search idea. It could be perhaps delivering questions to students in a way that optimizes the efficiency with which the student completes or undertakes the assessment. So that was just one thought we had, that just moving up step by step by step, moving up a pathway isn't necessarily optimal. And I think maybe that's the second point as well. I've sort of bundled both points into the same point.
Well, I think the other suggestion there, Jim, is once it's exhausted a path, it randomly chooses, or it picks halfway through the list of incomplete topics. There may be some topics where we could get more information about the student's abilities if, rather than being a random topic, it was using some of the characteristics of the knowledge map.
Yeah.
So by applying some graph theory and some Bayesian logic, it might be possible to get a more efficient algorithm out of this.
Okay, so this is not the most exciting slide, this one. But we just want to make it clear to you, what the data looks like in its raw form. It comes to us as a huge JSON file, 100 meg or something for 715 attempts. And R does a great job with a few packages of allowing, sort of easy exploration of that data and kind of restructuring and cleaning. So all that's been reasonably straightforward in R. One of the sort of main... Yep, sorry, Don.
Sorry, I was just going to say, we should also say we're running an LTI server for Numbas, so that's where this data is coming from. It's the LTI server. Yeah.
Yeah, so one of the main tasks in cleaning the data is just to remove these null cases where students haven't responded to any of the questions. They've just got a string of NAs against all the 50 questions in the tool. So a sort of a brainwave that Don had was to use the iGraph package in R to ultimately import the knowledge map, to bring this knowledge map, which Don built in Gephi, bring that in to R and be able to use it to create what we call a set of implied scores. So by that I mean, if a student gets, let's see, if a student gets 101 orders of operations wrong, then by importing the knowledge map into R, we'll be able to say, even though there's an NA against these questions, which are harder according to our knowledge map than order of operations, we're going to assign a 0 to each of these. So the zeros sync. The zeros are propagated down the knowledge map from easier to harder. And so that's something we've been able to relatively easily do by actually having a set of references, the in and out vertices they're called, for each node in this graph. How am I going for time? Do I need to sort of skip along a little bit, or? I'll keep going.
I think we're about 5:2, Jim. So yeah.
Okay. All right. But we've got a bit of time after, haven't we?
Yeah, we have.
Yeah. Okay. No worries. Okay. So as we said, the zeros sync, the ones float. Basically, it's a good guide here with this graph. And so you can see, for example, that for let's see here. For question 1, which is, according to iGraph's indexing system, is this question order of operations. That propagates down to 2. So a 0 would propagate down to a 0 for 2. A 0 for 1 would be a 0 for 2. A 0 for 1 would also propagate down to a 0 for 3 because it's harder than 1. And similarly for 1 to 6. Up the top here, this isn't actually a question. That's just a reference to the learning outcome within which all of these questions / topics are grouped. Okay, so we're pretty fast and loose with how we dealt with partial credit questions. If a student got 30% on a question, well, we were happy just to give them a 0 for that. We didn't do any rounding or anything. Obviously, if they got a 1, that 1 was sort of preserved. So the sort of the difficult task in now, generating implied scores from what we've been calling raw scores, actual student responses, was the difficult task there was to just kind of work out how to actually use this kind of information in R to ultimately do the propagation that I've just talked about in both directions. Zeros dropping, 1s floating. So we did that. We did that for 359 attempts. They were complete attempts in the sense that after applying this kind of implied scoring algorithm, we generated complete sets of implied plus raw scores. All 50 questions had either a 0 or a 1. That then set us up really well for use of rash modeling. And so that's what we did here. We used rash modeling in a very fast and loose way to generate a set of item difficulties measured, in the logit scale, log of odds scale, a set of item difficulties for the raw scored items, and similarly for the implied plus raw score. Let's just call them implied score items. So they're down column 6 here. These are the raw item difficulties. Column 14, these are the implied item difficulties using different data sets there. You can see, for example, all the number of items for the implied score is 359 because we've got a complete set of 1s or 0s for every question of the 50 questions. Here for the raw data, you've got a lot of NAs in there. So for example, question 11 was only attempted by 62 students of 359. All the rest were NAs. Okay, so then what we did, we now got these item difficulties as measured by, by two models generated here. And what we're interested in is looking at situations where the ranking, easiest to hardest, the ranking of the difficulties was significantly different. And so what we found, for example, for question 11 here, this had the biggest difference. So question 11 was rated after we'd applied the implied scoring algorithm, was rated as pretty easy. But as a raw score item estimate in terms of difficulty, it was relatively hard. So what's happened, we believe, is that in this case, a lot of 1s have flowed in to this question. So the propagation, when we apply this implied scoring algorithm, the propagation has assigned a lot of 1s to cases, to students, and hence made the question easier. More 1s relative to 0s probably means that the question is measured as easier. All right, so then that's a point of focus. So really, the whole sort of purpose of this is to just give us some kind of focus. Is it going to give us any information? Can it take us back ultimately to the questions? Can it take us back to the knowledge map and allow us to probe that and interrogate that and find problems in it, gaps in it, inconsistencies in it? And I think in this case, it actually has. So if we focus on question 11 here, this question is fractions as division. I'll show you what the question looks like in a second, but in the knowledge map, it sits here. It has a number of out nodes attached to it. So 205, fractions as division. I don't know if you can see this terribly well. Let me see if I can zoom in a touch actually. No, it's not going to work. 205, fractions of division. The out nodes are the nodes below it. And these are, questions identified as 13, 14, 16, and 15. 13, for example, is 206. This one quantity is a fraction of another, which is this one here, 206. Okay, so the out nodes are the nodes below. The in nodes, for question 205, are the nodes above. So, for example, this one here, 203, lies above it. So what we actually found is in this particular case that this question 11, fractions as division, has been given a lot of ones, perhaps yeses. It's been rated as mastered using the implied scoring algorithm in cases where perhaps that wasn't justified, that wasn't reasonable. And the reason it would have been assigned a 1 is because of the propagation upwards. Students would have answered harder questions down here correctly, and the ones would have flowed up to this. So let's have a look at question 11. Okay, now on the left, this is the question. I'll just go back. This is the question here, 205. It's above the other one, and hence it's easier, the other one being question 15. Okay, so imagine a student gets question 15 correct. Then what the system is going to do, or what we're going to do using our implied scoring, is we're then going to say that this student has also got question 11 correct because we're propagating the ones up. But if you look at part B of question 11, it's actually quite a tricky question in comparison to, for example, either of these two parts of question 15. So it's drawn our attention, we believe it's drawn our attention to a problem, and I think we need to actually redesign question 11, and we need to also think about some of these connections in this part of the knowledge map. This is clearly dysfunctional. This set of implications is not working, and so it's going to need attention. And this is just an example of where we think that with this pretty crude analysis at this stage, just using rash modeling, where we've been able to, focus on particular areas of sort of concern within the knowledge map, and then hence, the associated questions in the tool itself. And I think that is all we have. So thank you.
Well, thank you, Don and Jim, for your presentation. It is a very interesting topic, at least for two reasons. First, of course, because we all know how important it is to have a kind of a diagnostic test and diagnostic at the beginning of our courses, especially mathematical courses. But on the other hand side, it is also interesting because it is this knowledge representation and map and algorithms, so we can discuss both. Let me see if there is any question in our Q&A. Nothing for now, but I can see that at least two people, Colin and Sam, they are typing here, so we can wait for them. Let me just ask you, in the meantime, did you ask your students about the benefits, like questionnaire for students to get some feedback on that.
Well, we haven't done any evaluation yet, but Don, you actually had some students pilot one of these diagnostic tools, didn't you?
Yeah, it was very hard because it was in the summer session. It was very hard to get students to pilot it. So the couple that did go through it felt that it was beneficial. They thought it highlighted gaps in their knowledge. And I think, again, purely apocryphally, I think some of my students from Maths for Engineers preliminary have found the same thing. By doing this at the start of the semester, they realised that there were gaps that they needed to address before we got too far into the process or into the semester.
One thing that's been really interesting, just looking at these things called partial order knowledge structures, POCS techniques, that are kind of I think they're called naive Bayesian networks. Is these kinds of techniques of using the response data from not from the diagnostic tool, but if you imagine that instead of having 715 higgledy-piggledy attempts care of the diagnostic tool, you had 715 complete raw attempts where every of the 50 questions in the tool had associated with it either a score of 0 or a score of 1, then these POCS techniques and other related techniques could be used to generate knowledge maps ultimately. So in the literature, I've seen them referred to as implication networks. So A would imply B, question A would imply question B, question B would imply question C, but also question D would imply question D. So these sort of automated techniques for generating knowledge maps, that's really interesting to us, but we can't do that yet because we don't have the right kind of data. There's too many gaps in it. We would need to have a sample, not necessarily a large one, but we need to have a sample of complete raw response data. Sorry, I went a bit off topic there.
Yeah. There's a couple of questions or a couple of things in the chat.
Yeah, there is in the Q&A. Would you like Don to read it by yourself? Because there are two questions.
Yep, sure. Yeah, so Colin said they also make a point of using the term diagnostic exercise. Students still call it a test, though. What message do students get following the diagnostic? Do they get work suggested? I thought we'd had a slide in there with an image of the results. What they get is a response that gives them a percentage on each of the learning outcomes. So the diagnostic test gives them a percentage, and then there's a threshold set which we reset to 80%, so that if they score less than 80% in a learning outcome, there's a message comes up at the bottom that says that you should focus your attention on this learning outcome. It doesn't go any further than that, although that's something that Jim and I are talking about, and a few others in MESH, because we may have a bit more money this year, of trying to give something more directed to the students for suggestions.
Using, dare we say it, generative AI. Well,
yeah.
Not live though. So one idea we had was to have, something like ChatGPT generate model answers to some of these simple questions, and then for us to curate those. So there might be a set of, beautifully formatted and presented step-by-step answers to, a problem involving fractional arithmetic, for example. We might be able to sort of generate 4 or 5 equivalent versions of that, all lovely and elegant and thoroughly curated by us. And then we could build them into a system that is attached to the tool, such that if students are found to be deficient in that area, that it then directs them to, one of these step-by-step, sort of generative AI generated models solutions. It's just an idea at the moment. We're just playing around.
Yeah. Potentially we can point them to other learning objects as well, but focus particularly on what they got wrong. Sam's also said it seems tricky to identify issues in the knowledge map itself versus whether a question testing an item from the map is too difficult, or perhaps uses some additional skills without these being properly recognised, which, yeah, I completely agree. Do you have any comments on this? Sorry if you answered, I missed a couple of minutes as my daughter arrived home. I guess for the knowledge map to be effective, one needs questions which test the items in the map very purely, and so later analysis is simultaneously checking the fitting of the questions to the nodes of the map at the same time as testing the map itself.
Yeah.
I would completely agree with that. I think really what my gut feeling at the minute is the testing that we're doing is really testing the fit of the questions, and it's kind of assuming that the knowledge map is accurate and correct. And if we can possibly go back to that process that Jim mentioned of getting a small group of students to attempt all 50 of these questions, and then use the process which most of the research seems to suggest for generating the knowledge map using some Bayesian analysis or various other processes, we could then check whether our knowledge map is close to what's generated by that as a way of testing the validity of the map itself. So I think really the testing that we're doing now is highlighting questions where we haven't quite got the level of the question right. So I hope that answers.
Okay.
Okay.
So you have two times thanks from Colin and Sam for answering the questions. So if there are some other questions, please type them, or if you would like, you can also use your voice and ask questions here by your voice using the audio.
Yeah, I'm very happy to talk to people. It feels a bit strange talking into the void and just reading the answers.
Yeah, that's right.
If anyone wants to ask a question directly.
But since we are actually recording the session, some people are reluctant, so it's better for them.
Sure.
But yeah, if you would like anybody, if you would like to talk to and use your voice and ask questions or put some comment, Sam, you can do it. Yeah.
Yeah, sure. Can you hear me okay?
Yes.
Yep. Yeah.
I just wondered whether you had any comments on whether you thought these knowledge maps were affected by the prior teaching, and in particular, does your knowledge map with whatever your curriculum of teaching from pre-university, would you suggest that that's going to be the same knowledge map for, say, me in the UK with my students going through the A-level system? Is it really devoid of the previous syllabus or not?
In this case, I'd say it is, because what's covered here is very basic algebra and arithmetic. I mean, this would, in Australia, there's nothing in here that would be covered after about year 9, I wouldn't think, year 10, so junior high school level. So I think it's fairly generic. As I said, when I first started looking at this and trying to figure out exactly how to build a diagnostic test, I reverse engineered Christian's diagnosis, which I think goes back even before the Numbas system. And the knowledge map for that, the concepts there are very similar to what we have here, although it's a much broader scale diagnostic.
Okay.
Sam,
any other questions here?
Just a quick follow-up there. So Sam, were you at least partly asking also about cultural differences possibly in how maths is learnt, or how curriculums are designed?
Yeah, I guess. I'm not quite sure what I was thinking the differences would come from, though one could imagine that might be the source of some differences. But I guess I was also thinking, you know, to what extent should we expect knowledge maps to be universal? So, you know, if you're talking about trying to check whether this knowledge map seems to fit, well, it seems like we might be able to answer that as a very large community of people if you believe that knowledge maps are universal. Whereas if there's something that affects this knowledge map based on the teaching before, then we get into a more difficult position, right? Where you guys need to make sure that this is the correct knowledge map for you, and I would have to make sure that I had a correct knowledge map for me.
Yeah.
So I was just trying to get a feeling on whether you thought, I mean, I guess my gut feeling would have been, as Don said, that these would be fairly universal, but I just wanted to hear your thoughts on that.
Yeah, no, I think it's really interesting, especially when you think about the design of the questions, because I reckon that you would find cultural differences there. You know, and I've read about that as well, you know, in the context of equity in maths education. So, you know, minority groups, for example, in America, North America, you know, they, when they're exposed to different types of mathematical lessons and questions and so on, respond differently to, you know, majority white, you know, sort of subcultures. And so I think at that question design level, that's a really interesting problem. But, you know, the deeper one about, you know, what ultimately are latent traits, I suppose, you know, we're talking about skills here associated with each node in this graph. Not sure about that. I suspect that there would be cultural differences as well, but perhaps they're not as easy to identify as the ones that would affect question design. Anyway, really interesting.
Yeah, and not just the skills, but the sequencing of them, right? I think that's the other thing.
Yeah. And also it depends very much on the delivery of the curricula in pre-tertiary education. And yeah, there are different traditions and approaches to that. Ingo, you would like to ask the question?
Yeah, well, first of all, thank you very much for this talk, and it would be nice if you could provide the knowledge maps in a kind of machine-readable format, somewhere through the forms, at least for further reference for your own experiments. But I would like to make a remark on the uniqueness of the knowledge map. I would expect that this depends also on the way you are teaching. In particular, when you go for advanced mathematics, then you have several theorems that several mathematical concepts are equivalent. And it's up to the teacher to what to teach first and what are the derived concepts, then in which sequence to go through. So I wouldn't expect to have a DAG in more complex domains.
Yeah, I agree. It very much depends on curricula itself and the sequence of teaching and learning activities, and yeah, how we actually, what kind of a learning design we apply here. Okay, let me see. No questions here in chat. Anybody else would like to contribute here? Ask questions or comment what we have? No. Then let me thank you, Jim and Don, once more, and all of you for participating in this session. And of course, I invite you to participate in other sessions this afternoon, European time, this time, and then in following days this week. So thank you very much, and I hope to see you at some other sessions here at the conference. Bye.